And welcome to tonight's session, and we're going to begin immediately. And we're looking at a target of next month. The things we still need to learn, it's still very much. And what I'm actually trying to do is to make sure that make sure I cover everything that we need to know as a foundational knowledge, so that once you look at Python or any programming language, you can actually use the skill that you've learned here to apply them. I want you to be like, when you see something that is basic or foundational enough, you actually say, oh, I've done this before in this particular edition. So we'll be fast as much as we can. I believe you guys already understand a lot of things already, so we'll not really dwell on things more again. If at any point you don't understand, you could always check it out on Google, or find a way out by yourself, because I believe you guys, for you to reach this stage, it means that you have all it takes to learn faster. You're no longer a beginner like that. You're actually gone into the intermediate level of the basic knowledge of Python. So let's just go straight to what we have tonight, and we'll still continue with our tuples, and let's get started. I'll be sharing my screen at some point. Okay, I will be sharing my screen shortly, not at some point. Okay, so okay, so I believe you can see my screen. I want to confirm that it's very important. Please confirm you can see my screen and you can also hear me loud and clear.
Yes.
Okay, all right. So I think where we stopped in the last class, I'm looking at it right now, and that should be when we're trying to get this done. I can remember when we're trying to, let me connect the collab. So I remember when we're trying to work on this, we said something about this particular looping, but once you go through an iterator, we do it only once. So we did that in the last class. We saw how it worked for us. So let's run this particular line again, this particular cell again. You can see it has stored an object here, and if we try to run this now, it's going to come out as the list, a list. Okay, but inside this list there are tuples inside of it, because you can see there, you can see here, a comma 10 is inside a parenthesis, the normal bracket, which is always representing a tuple. So this is a list of tuples inside of it, and let's get started. Let's just look through this particular zip list that we have defined here. So for Z in zip list, we print Z. So if you print Z, it's going through each of the elements inside this particular zip list, and you can see it brings out each of the element, which is A10, B20 till we get to E50. And we want to assess it, we assess it using the indexing of it, because this automatically has become a list of tuples. So each of these is being seen as a single element. So you can see here, you can use the indexing, because lists are ordered and they always assess the elements inside the list using the indexing of the index of that particular element. So by the time you check the index of 0, it brings out the first element, which is A, and A comma 10. Okay, so the next thing we want to do right now is, what happens if the parameters are different in length? That means if the first one is A to E, this particular one is 10 to 10, 20, 30. That means 3 elements. This other one is 5 elements. What is going to happen? So that's what we want to check it out now. So if you do that, we create a new zip. Remember when we said trying to zip this, we're bringing two structures together, and this particular one, they are definitely of the same data type, which is list. So we bring in D1 comma D2 in together. We are zipping it using the zip function, and we print it out. By the time we print it out, it's being stored at an object, zip object at a particular address. So assigning this zip object to a list, as we used to do before, we want to make sure that this particular zip thing that we have done now, we are attaching it to a list. We change it to a list. So zip list equals to list. We are changing it to list now, this tuple to list. And remember that anytime we use the zip function returns tuples. Remember, it returns the output to be in tuples. So we are changing that tuples to list. And how do we do that? By bringing the list operation here, and we call out the name, the zip, what they call a variable that we have gotten to change to a list. By the time we do that, we call out the zip list. You can see it brings out the list of tuples itself. So you can see it A, 10, B, 20, C, 30. It doesn't pick the that of D and E, because it doesn't have a lot, then the element enough to match up with this other one. So it doesn't take it at all. It will not take it at all, and it will not give any error at all. Remember when we're doing the what they call it, the unpacking, then the tuple assignment, even when we not use the zip function at then, by the time we could have done this, it could have given us an error. But this particular one, it takes what it can take and doesn't throw any error. And if you call out the length of this particular zip list, you can see it gives us the 3. So the answer is going to give us the minimum number will decide the final word length. The minimum number will decide the final length. So the minimum number was here, we used here was 3 in the particular element. So it discards the other ones that are D and E. Okay. So by the time we call out the length, you can see it now becomes 3. It takes the ones it can. So by the time we now say, okay, finally, okay, let's look over the zip list. Let's see what we can actually have. So how are we going to do that? We're saying for EL, I'm using anything right now. So EL in zip list. Okay, so each of the elements inside this zip list, I want you to loop over them. And as you're looping over them, I want you to print those elements, that is EL. This EL could be anything. And as you're also printing them out, I also want you to print the type of this particular element of this list. Okay, so if you can see the outcome here, you can see that it comes out A, 10, and also prints out the type as well, which is class tuple. B, 20 class tuple, C, 30 class tuple. Okay, so now the next thing we want to look at, okay, I would like to stop here at some point. Any questions? Any questions? Please, any questions? Okay, please, if you permit me to go ahead, you can tell me to go ahead, or put any emoji to tell me to go ahead.
Sorry, please, I have a question, sir.
Okay, Mr. Funso, you have the floor.
Please go back to your code.
Okay, I'm back to my code.
Yes, line 1 for EL in zip list. Where do you see the EL?
Oh my goodness, Mr. Funso, what did you say?
Sorry, for EL in zip list.
Okay.
Hello. So
Yes,
where did you see the EL?
Okay,
where did you see the EL from?
The EL is an arbitrary variable. It doesn't have to mean anything. I'm using it. I'm just using it. I can name it anything, but it's going to.
Okay.
The EL is the value for each element of this particular zip list.
Okay. All right. It's clear. Thank you.
Okay. Thank you. Any other questions? Okay. All right. So I believe the silence is carry on. Or you guys may not even be in the meeting. How far? Hey.
Yes, please go on. Go on.
Yeah.
Okay. All right. So we'll go on. Welcome, Mr. Manuel. So what we have done now is the next thing we want to do is the tuple unpacking. That means this particular A, 10, B, 20, C, 30, we want to unpack them. We want to bring them out by ourselves and see how we can make it work for us individually. And you can see what I did here. Tuple unpacking, you can see for D1 underscore EL, comma, D2 underscore EL in zip list. Why am I doing this? Because I know that I'm trying to unpack things. I'm trying to unpack the zip list, and each of the element contains two values, which is B. There's a one that has A, comma 10, B, comma 20. So what it is doing right now is that each of these will be taking each of the elements inside the group elements. Now, inside a tuple, there are two elements inside of it. So this for D1 underscore EL and D2 underscore EL will be for each of the elements inside the tuple of that particular zip list. So you can see here, if you can see here, so we now said for D1 underscore EL, comma D2 underscore EL in zip list, we print. What are we printing? We want it to be assigned in a way that we can actually, it can make sense for us. So as we are unpacking them, we are also packing them in a grand style. That's why you see we're doing elements from D1 colon. We'll put, remember that we're using this particular format method. You could have used the F string. I love this one as well. So you put the first element here, which is going to represent D1 underscore EL, which you put in a curly bracket, dash element from D2. You put it in a curly bracket 1, which represent D1 which represent D2 underscore EL. So you can see here dot format. We put in the values here, the variable that we have defined, the arbitrary variable that we have done in that particular for loop. Okay, so by the time we print it out, you can see the outcome here. Element from D1, that is the D1 that we had here, which is A here, and element from D2, which is 10 here. You can see each of them as it is looping, it brings them out all by itself. So you can see B, and there's 20, C, there is 30. So that is what tuple unpacking is inside a particular list. Okay, please, at any time you have questions, please, you can always unmute yourself and ask, because if you are raising up your hand, I may not see because I'm sharing my screen. So the next example I'm going to look at is, how can we check the corresponding elements at the same index of two lists? This is a very popular question as well. How can you check the corresponding list elements at the same index of two lists? Okay, so and print them if they are equal, common elements. So if they are equal, this is what I want you to do. Okay, so we now define two list variables here, L1, A, B, C, D, E, and you take note of their cases. The first L1 here, the element here is a smaller case, a lowercase, uppercase, uppercase, lowercase, lowercase, and uppercase. And the same thing with L2, there are different cases here. But now we want to find out that which of them have the common element and they are on the same index as well. So how do we go about this? We now said, okay, we zip it together. First of all, we have to zip it. So you can see here in this particular for loop on line 4, for E1, E2, I could have named it anything at all, but I decided to use E1 and E2 to represent each of the elements of what L1 and what L2. Okay, as you are zipping them together. For example, A, lowercase a and uppercase A will come together into one, and this particular one, this E1 will represent the smaller case A, and the E2 will represent the uppercase A, something like that. So now the condition is, if that E1 equals E2, that means if they are of the same ASCII number, all those kind of things that try to represent, how do you know that it is equal? If they are the same cases, the same uppercase or the same lowercase as well. What do we want to do? We want you to print only the first element of that particular zip, what they call it, elements inside this particular zip element. We want to print only the first one, which is the E1, which is going to be the upper one here, because we have referenced this one to be L1, L2. If we put this L2 first, it could have been the other one below. So by the time we do that, print E1, you can see that the outcome here will be B, D, and F. And you can check it very well. Is B, look at this B and B here are the same cases, and D and D here are the same case. You can see they are smaller, the lower cases, and F and F are the same cases. So that is a practical example of how we do make this work for us. If it was more than one list, maybe it was 3 lists, you could have done the same thing. Then when you are doing this, you can say for E1, E2, E3 in zip, you put your zip, do the same thing, and make it work for you that way. There are ways you can go through it by yourself. You have gotten to a foundational knowledge, so you can try experimenting things by yourself. If you get an error, check on Google or ask me directly, and I will be able to find a way out for you as well. So the next thing we're going to look at, I'm looking at a way that we can actually finish up tuples tonight, so that the next thing we're looking at, we can use next week. So in the next class, we can just finish up set and the other one, so that we can go to our next project and see who will still stand strong, because you have been doing more of theory so far. I feel guilty at some point. I feel you should do something hands-on by yourself. Okay, so let's go to tuples and dictionary. We have tuples, we have dictionary. How can they come to relate with themselves? How can they relate with themselves? Please, if you have questions, if you have anything that is disturbing you at this stage, please ask me. Anything that is disturbing at all, no question is wrong. No question does it seems that you don't understand anything from the beginning. If you are completely lost, except you came in late at some point, and you can still ask, maybe that won't be after the class, so that you not drag everyone backwards. Okay, but if it's something that you feel that you know and you feel that you should ask, please unmute yourself and ask questions as well. Okay, so we'll go into tuples, tuple and dictionary. How do they relate? How can they come together and work as one? So we learned that to get elements of a dictionary, we use items. I remember when I said that, because why is this so? Because dictionaries are unordered. They don't have a particular order, and you cannot give index to dictionaries. So we use the items to access each of the elements inside a dictionary. So, and this item returns a list of tuples. I remember when we tried to get it, it returns a list of tuples whenever you try to access them. So, excuse me, we want to get the ASCII code for first 3 letters. We have done this particular thing. You can check on Google and check the meaning as well. It's a standard number that we use. So we name a particular dictionary. I put it in a curly bracket. Please do not look at how I'm arranging this right now. You can have put your own in one line, as far as you put a comma and the next one comes in. So this is the key, and these are the values. Okay, you can see this ORD that you are seeing here is a particular kind of, let's say, a function that is used to check the word, to bring out the ASCIIS number of these particular letters that we have put here. So anytime we are putting this particular dictionary, is just showing that the key here is A, and the value that is going to come out is going to be the ASCII number of these letters. So you can see here, by the time we call it out, we call the ASCII dictionary out, we can see that this is what it gives as the dictionary itself. So this is the main dictionary right now. The dictionary has come out in full form after checking the ORD, which in this particular case is the ASCII number. Okay, so you can see that of the capital letter A is 65, that of B is 66, and so on and so forth. So the next one we're going to look at is How can we, when we call out the dot items method, what does it bring out? You can see it brings out a list. It brings out a list of items, and these items are in what are inside tuples. You can see it comes out as what tuples inside a particular kind of what list. So you can see inside here we have a comma 65 is inside the bracket, b 66, c 67, cap small letter a 97, and so on and so forth. So how can we now look through them? We now say for key comma values in this particular dictionary name dot items. That's how you can look through dictionary at some point. By the time you print, what are we printing? We want to print the key and also the value. You can see by the time we print it out, the key comes out as A, the value comes out as 65 until we go down till C, which is 99. Now, dictionaries are not ordered types, so we cannot expect items to be ordered as well, because dictionary does not use implicit integer indexing. By the time we call out the name of the dictionary and use the normal indexing to check it out, it's going to give us a key error because it doesn't work with dictionary. Okay, so how do we make it work with dictionary? By trying to convert that tuple list. Okay, convert the tuple list into a particular dictionary. And how do we, okay, sorry about that. To convert tuple, this is another subtopic on its own, sorry. To convert tuple list into a dictionary, how can we compare a tuple list inside a dictionary? So this particular one, if you wanted to access each of the elements, you use the key. Remember when we taught the dictionary, if you want to access each of the values, we access it using the name of that particular key. So if you wanted to get 65, you will just put a here and it will come out for you. So now the next subtopic we want to look at is how can we convert a tuple list into a dictionary? So we saw that items return the elements of a dictionary as a list of tuples. Now let's do the opposite. This time we will have a list of tuples and convert it into a dictionary. So how do we make that work? We bring out the months, or this way we are using the months of the days of the months, like, and we'll just put months underscore days equals to. Now this is a list of tuples. If you can look at it very well with a technical eye, you can see I started with a square bracket, open and close here, and inside of this particular square bracket there are tuples inside of it. You can see January is in in the normal bracket, January, 31. That's one of the elements, which is a tuple. February and the rest until we get to the last. And by the time we call out the month days, you can see how it comes out. There are lists of tuples. So how do we change that to dictionary? Just simple. You can just say month equals to DICT. This is the function to change to what a particular data structure that we have, which was the list of tuples, which was months underscore days, to what dictionary. You can see if we call out the month itself, it will come out in form of a dictionary. You can see January 31st, February, and so on. It is separated by a colon, and we have comma. It has column inside the element itself and separated by a comma. Okay, so if we print the type of months now, it's now class dict. That means that it is a dictionary. Okay, so we go on to another example, a practical example here. How can we make this work for us? Use zip and range function to create a dictionary of days in a week. So you can see here, we need the zip and range function. That means after we do that, we want to zip them together and make it work for us. So you can see the solution here. I created a list of the names of the days of the week, Mondays through Sundays, and I called out another name, since they say we should use the range, we call numbers equals to range. You can see I'm putting it 1,8. I did not put 1,7 because If you do that, it's not going to work for us, because this 8 will not, if you put 7, it could have picked only 1 to 6, but since we need 7, we added 8, and this 8 will not be inclusive. So by the time we do that, we create another variable, days equals to zip, open and close brackets. You can see I bring out numbers here. Numbers, I want to use numbers first, and the days of day underscore names will now come in later on. So if you print it out, it's going to store as an object, and by the time it stores as an object, it's going to come out in form of a tuple. For short, zip always returns it in tuples form. So by the time we now said, okay, let's convert the zip object, remember is a illustrator of list of tuples is a tuple, so we convert it to dictionary. So days underscore dit equals to dict. This is the conversion itself. And what are we converting? We're converting the days. By the time we now print days underscore dit, is going to give us the key and the value, which is 1 Monday, 2 Tuesday, and so on and so forth. So you can see here is a practical case. If at this point I'd used days first here and number second, Monday here could have been the key, and the 1 here could have been the value. So you can see how how these things are working. Remember that zip always returns tuple. That's why we change it from what tuples to dit. Okay. So we do the same thing in one line. For some of us that doesn't have this strength of going through all this protocol, it's a waste of time for us. So what do? We just do everything right from the same line. By the time we define this thing, this from here, from this particular line 3 and 4, we don't need to we just run it directly. You can see days underscore dit underscore 2 equals to dit here. So anything that is inside, we're zipping numbers and days together already. We know that it's going to return list of tuples already, but instead of that, we need to do what? Inside here, we're already going to change it to dictionary immediately. That's why we brought in the dict function here. By the time we fix it here, it changes the outcome of this particular here to dictionary, and by the time you print days underscore dit underscore 2, it's going to go straight to printing the dictionary, the days of the week, and the numbers in which they are, the position in which they are. So that is how we make it work for us, and let's see how it goes. So I believe at this point I've not heard anybody unmuting themselves and asking questions. It means that we are good to go and we understand what is going on. But if you do not, please ask.
Sorry, just a tiny question.
Okay, sir.
Yeah, if you could oblige me by going back to your screen.
Okay, sir.
Just scroll up a bit. Why was it from index 1 to 8 and not 0, since 0 should be the very first index?
Which one are you talking about right now?
Okay, just go up a bit.
The range, right?
Yes, the range precisely, yeah.
Okay. The range here is not acting as an index. The range here is acting as a separate data structure on its own that you have to zip together.
Okay.
Yes, the range here is not acting as an index. No, not at all. It's a range of numbers. That means it comes out as a list on its own. Range comes out as a list on its own. It's not a range of, it's not used for index.
Thank you very much.
All right, sir. Please, any other questions? Okay. If none, let's continue. So now the next thing we're going to look at is tuple as dictionary key. Tuple as dictionary key. Remember when we tried to we're doing something about hashable and unhashable data structures. I remember when we said something like that, we learned that the key of a dictionary must be immutable. It must be immutable. But if it is not immutable, it means that we cannot use it as a key. So since tuple are immutable, we can assign them as dictionary keys. You can see them here. So let's see a practical example here. I don't know if you can remember when we did something about this on hashable and on hashable and hashable data structures. Remember when we did something about immutability and which one can we use as keys and which one can we not use as keys in dictionary. Remember when we said we could not use list inside for keys because they are mutable and they are hashable kind of this thing that we did then. So now let's look at a practical example. We want to store the student's name and grade in a dictionary, and for sure the first and the last name we want it to be the key, and the grade will be the value. So let's see how we want to make it work for us. So you can see we create, this is the output we want to make. So let's see how we make it work for us. So the first solution is we define the list of names, the name, the first name, the last name, and the grades that in which these people have. So you can see names and the grades that they all have as well. And let's see how we can make sure this works for us. So the first thing we did was to look at the grades. We student underscore grade, we create an empty dictionary and we look over 3 lists simultaneously. Remember, we have never looked through 3 lists as well, but this is a practical example. I told you can actually make this work for you as well. So we can see for name, last name, grade in zip. I could have used anything in these names, so please, it's not because these ones are names, grades, and that's why I'm using them. No, I could have used anything. I could have used A, B, C. Okay, but as far as it represents this particular thing that you want to zip. Okay, so the first name here represent names, the last name here represent last names, which you have defined here, and the grade here also represent the grades as well. So what do we want to do with that particular line of code? Sorry, it's simply to do what? The student grades. Okay, you can see here the student grade that we define as an empty dictionary here. We are now calling it out by what? We want to use the name, comma, last name. You can see I'm putting it in a tuple. I'm putting it in a tuple right now. It means I'm using this name, comma, last name, which I'm putting here, which came in the for loop, as the key. How do we add elements to a dictionary? We call out the name of the key that we want to use and equate it to the value. So what we are doing right now is name, comma, last name equals to what? The grade and which we want to use. Okay, so by the time you print, we say okay, now call out the student grades that we have in that empty dictionary before. Now you have populated the dictionary. By the time you do that, you are going to see the outcome of it. You can see the outcome here. It comes out as, this one comes out as a tuple, which is used as the key, and the value, which is the grade, it's coming out as A, Bruce, comma, Wayne, DC, Clark, comma, Kent, FF, Peter, comma, Parker, FD. You can see how it comes out as a tuple is being used as a key in this particular dictionary. Okay, you can see how it's working for us, and it is fantastic as well. So at this particular okay, I believe if there were questions, someone could have unmuted themselves and asked the question. Okay, so if there are no questions right now, permission to carry on, and let's proceed. Okay, so the next thing I'm going to look at is the lambda function as a key. We have been using tuple as key, we have used tuple as key. Now the lambda function itself. So I remember when we have talked about lambda function, we said that instead of going through series of lines of functions and try to get things done, we always declare a lambda function as one line and we make it work for us. I know we have taught lambda function, maybe you have forgotten at some point, but I believe by the time I show you something tonight, you'll be able to understand the lambda function. Man, it's good to feel fine. Remember the last class I was struggling to even say one or two things in my head. Thank God for life. Okay, so lambda function as key. Some built-in Python function expect declaration to execute. We have to declare them how to process, blah blah blah, and okay. So we can actually we saw a lambda function before. Now we use a lambda function as function parameters. Nevertheless, we're going to see a practical example. The main thing I want you to look at is the example I want to. For example, if you want to sort out Python as two functions, we have for sorting out Python, it has two functions. We have the sort and the sorted. Okay, and how do we use the sort? We call out the name of the list itself and say dot sort. This particular one does this how it works for us at some point. Don't worry, we're going to see a practical example of this example I'm giving here. Sorted, how is sorted done? You just call out sorted and put everything inside that particular bracket. So this key that is equals to my function is more of like you are defining a function on your own. And as you see, the my function, we pass to key parameters is our function. First, we'll create a normal function and pass it to a key parameter. Please pay attention. We'll create a normal function and pass it to a key parameter, and that's how we're going to use this particular one. May not be the direct lambda function. We're just trying to use a function itself. Then after we'll now use the lambda function instead of that my function part. We're going to see it practically as well. So so you can see then we do the same thing with lambda function. So the first thing is the normal function that we know. Okay, we are defining cars. this is tuple itself. Okay, so this is a tuple. Why is it a tuple? Because they are inside the normal bracket, and these are cars. We have the names of cars, and at some point I had to put them, this particular one, as initials as well. So so the first example is sort the cars tuple by length of their elements in ascending order. That means each of these elements, their length, as it is, as the length, maybe BMW, the length is 3 right now. You know how it is, you put it in ascending order. Which one comes first? The smaller, the bigger, the smaller, the bigger, and the rest. Which one is either in descending or ascending order? So let's define a name function, okay? And you can see here, you define a function by using def, the name of your function. This is my function that we said we want to use, and we're passing a parameter, and this parameter is e. It could mean it could add anything. And what do we want to return in this function? What is the main function? What is the main what they call it of this function is to return the length of the parameter of the parameter they are going to put in here. So now we can see if we call out the function my function and put Audi here, and if you run the code, call out the function and run it, you can see Audi has 4. The length of Audi here is 4, is going to return 4, and the length of VW here is going to return 2, because that is the length of these particular parameters. Okay, now the main idea of what we want to do was to sort the car's tuple by the length of the elements in ascending order. So that's why we're now bringing the sorted and the sort methods or functions here. So you can see here, we call the sorted now. We put inside what? Cars. We now call out the cars itself. What are we sorting? The cars itself, and we equate this key to what? Can equate this key as a parameter on its own, and I said key is equals to what? My function. That means that particular function that we have here, what was the function supposed to do? The function is just to return the length of a particular parameter that is passed, and those parameters are inside the what? The cars. Okay, is inside the what? The cars itself. You can see the variable, which is the cars. On all these things that we want to do, we want to perform it on the cars. By the time you call out the sorted function out and bring it out, you can see that sorted it out in arranging in ascending order. The VW is the smallest, BMW a Audi, and the Mercedes will be the last, and that's how we use the sorted in this particular function for the key equals to my function for sorted, and you are using the cars. Now you can see if you want to use sort, sort is a list function. It operates on list only. But if you can see in this particular one, if you can see in this particular one here, you can see here, it will not work for, let me, I want to check something now. The cars itself, you can see cars.sort. You can see cars. When we define cars at that first time, we did not define cars as a list. We define cars as a tuple, and sort is a what? Is a list function. But if you see cars.sort, cars that we did here was a tuple, so it's not going to work for us except you use the sorted, and you can see how we did the sorted. The sorted can work at any point. It can actually work here, but in this one I need to return a list value, a list data structure. But this one only works, it only specifically for what? The list itself. So as you are calling out the method, the function here, when you say dot sort, it goes to the cars and said, I'm only meant for only list, but you are a tuple, so I'm going to give what? An attribute error. Tuple object has no attribute. Sort does not work with tuple.
Sorry, sir. Sorry to cut you.
Okay, yes.
My hand is raised. Yes, I have a question.
Continue.
Let me see your screen,
yes
please.
Okay, sir.
So you said sort is a list function and it will not work for tuple.
Yes, because
right?
you are calling it directly.
Yes. What if we turn these cars to a list first before we use the sort function? Will it not work? Like for instance,
work,
okay,
yes.
it will work. I just wanted
yes.
to know.
Yes, it will
Thank
work.
you.
It's because you have changed it to list now, it will work.
Yes, I just wanted to know.
Yes. And if there are any other question, do like that, or kind of mute yourself and talk to us. Okay. So you can see here, if we call it out, it's going to give you a tuple object has no attribute sort, so it only works for list. So what do we do? Exactly what Dr. Kwemi has said. We change the words, we change it to list. Now you can see we now create another variable, cars underscore list equals to list. This is the listing. You can, if I keep here for a long time, you see list, okay, built-in mutable sequence. If no argument is given, they do what? Let's see, the constructor creates a new empty list. Okay, the argument must be an iterable if specified. So this sometimes, if you are, that's one of the basic things of using Colab. It gives you an explanatory knowledge of what you are using this for. So we are changing the cars from a tuple to a list, and we will print it out. If we print the cars out, we are going to print the cars list out first. We're going to print the cars list, the first car list, before we sort them out. Now we are going to sort the cars underscore list. Now we have changed to a list dot sort. Now say key is equals to my function. That means this, what are we sorting now, is going to be, is going to, what is it supposed to do? This my function is to return the length of that particular car list. So once it returns the length, it's going to use that to do what? Sort it for us as well. Okay, so this one we're just trying to print it after the sort. This is the result of the car list. So you can see the result here. This was before we sorted it out. Mercedes came first. I'll do BMW, pouch, VW. This is how it was. But after the sort, you can see it comes out as VW, BMW, Audi, pouch. Is it Porsche or I don't call it, or I don't know. But Mercedes as well comes in last. So you can see how it works for us, and now see how it happens. So the next thing we want to look at right now is the lambda function. The lambda function. Lambda function is simply what? A one-line anonymous function. I like calling it like that. It's a one-line function. Like you can just use one line and everything works for you at some point. So why is it called anonymous function? Because sometimes you might feel like when you bring out the values out, the variable you are defining immediately, you can this is something we could have just taken it step by step, but we're going to see it as well. So the very first one we want to use is the sorted for these cars. You can see right now, cars that we have defined already, we know the values of cars. That is Mercedes, Audi, BMW, Porsche, and VW. So by the time we call out the sorted, please look at how I'm using the lambda function now. I'm not using my function, my phone now. I'm using the lambda itself directly here. You can see I use sorted cars, comma, that key equals to my phone that I used before. Look at what I did. I call out and I did the lambda itself. The lambda is a built-in this thing, built-in keyword in Python. So I call it out lambda. Now, what am I calling out lambda for? The lambda is supposed to do a function. And what is this lambda going to do? The function is going to be applied on this anonymous kind of variable parameter that we're using, which is e. Could be anything at all. So lambda e colon, what is this e supposed to do inside this lambda function? We need to do what? To check the length of this particular e. So you can see it's a one-line function. No need to do all those initial that we did here. All these things that we did here, line this we don't need to do, just do it one line at once. So you can see lambda e, the e is the parameter which we are going to pass, colon len. What is this particular lambda function supposed to do? It's supposed to find the length of anything that we put in as e. So by the time we have done that, that e has already been taken place by the cars itself. So the thing that we're putting here is the cars, which is taking the place of e. So each of this particular length, which is the length of VW, BMW, will now be passed to what? They sorted, and that sorted will now take in, okay, this one is this particular VW is 2, BMW is 3, Audi is 4. Okay, let me arrange them and sort them out. Maybe Mercedes came out first, and that Mercedes is how many letters? How many? The length is I think we look at it now is 1, 2, 3, 4, 5, 6, 7, 8. It keeps 8 aside and said, this is not what it can't work. It can't start with 8. It goes to the very beginning, the one that has the smallest length, and prints it out like that. And you can see here we changed the cars underscore list to the cars from tuples to list again. We do the dot sort, and by the time we're passing in the key, you can see it's loading a parameter key support less than. You can see here these are things. So lambda e colon, what is it supposed to do is to check the length of that particular parameter, which is the cars underscore list. And by the time it does that, it sorts it out. And by the time it sorts it out, we can decide to print the car list. It does the same thing for us. Okay, but the only thing that you have to change it to a list first. Fantastic. So now we can say let's ask a question. So far we didn't pass any key parameters into sorted or sort. How do they do the sorting? Okay, so answer is they use standard word. Okay, someone wants to ask a question. Okay.
Hello, please, ma'am.
Yes, Mr. Sunday.
Hello. Okay. In lambda function, I don't know if you can hear me.
Yes, I can hear you.
The parameter e. Okay. How does the program understand that? I don't know the link. I don't know where maybe there's a way where we link that e. In the lambda function, I don't know how it will be able to understand that each of the car is that e. So that is my question. So maybe we have done it up before. I don't know.
Yes, we have done lambda before. I'm very sure we have done that.
So I'm talking about the parameter. I is able to get that the car is for that e. It's
okay.
One single function. So
okay. Now let's go back. Dr. Kwemi, your hand is still raised. You still want to ask a question?
Yes.
Okay, ask it. I'll just combine the two.
All right, thank you. You've just shown us how to sort like in ascending order. How do you
Yes.
sort in descending order? You've not shown us
We have
that.
done that before. We just say reverse equals to true or reverse
Okay.
equals to false. Any of those ones that we use. You can, before you now do not say reverse at the end, you could do comma reverse equals to. We have done that before. Just take
Yes,
it
we've
out.
done it.
Just reverse. Remember something like that?
Yes, I remember we did that.
Yes. So just do that, and that one will be okay for us. Let me go to Mr. Solomon Mr. Sunday as well. Mr. Sunday, if you look at, let's go to the function that we defined already. This function, we define a function here, the normal function here. You now say the function is to return the length of the e itself. This is a normal function. It's the same thing that we did here, just that we are using lambda here directly. Okay, now let's go to lambda. This lambda e is representing this particular class here. This e here is the class itself. This value for inside e here is the class itself, and we are looping. Yes, we are
Can I
actually
use
saying,
X
okay,
there?
yes, you can use x.
Okay.
You can
Like I
use
can use
x
any variable.
You can use any variable, and first you define that variable. Any variable that will come in will take in the values. It will take. You can use x, you can use y, anything at all. But the same thing here, it should be the same thing here. If it's e here, it should be the e here. If it's anything here, it should be the same here. If you wanted to use, instead of length, maybe you wanted to find a sum of this, you just put sum here and use it and make your work. But this particular one, we want to find the length of this particular parameter. In this one, are the names of the cars that we have separated by each of the elements.
Okay.
We have done lambda function. I'm very sure. I don't know if you can remember. Have we not done? Maybe I did it and I was not in this class. Please let me confirm so we can go back. Please confirm. Anybody can confirm that we did lambda, because if you did not, it's a very important concept. Okay, yes, we did. Done it. Okay, yes. Okay. Please, it's very important because lambda will save you a whole lot of stress, and it's something that is very wonderful. Okay, so we have done that. I remember now we have done it. Okay, so so the question is, so far we didn't pass any key parameters in the sorted or sort. It's because we do. How do they do the sorting? The answer is they use standard sorting. Numbers, they use numeric sort, and in numbers they use numeric sort, and also in string they use alphabetical sort. For example, if you put numbers here, 2, 1, 3, 72, if you call out numbers, it will give you that. But if you use the sorted numbers, it will do what? It will give us directly and sort it from ascending order, and it will do that well for us. And the same thing here, we just use the lambda here. We can just do normal lambda. It will still do the same thing for us and make it work for us as well. So it's no big deal. It's something that we actually understand. And sort letters or sort, you have to change. This one is already a list. No need to do anyhow. Just go straight to the point, and it works for us exactly as we did. And that's all. Tuple is done. Tuple is a done deal. We need to find a way to get to another data structure. Please ask your questions. Please go check anywhere, any tutorial that you see Tuple, and if any of those things that we have done together, everything in Tuple, check it out and see if there's anything we have not done, and that particular concept is not inside Tuple. I'm very sure that we have done, out of 100%, I'm very sure we have done more than a plus percentage of tuples, and each of those data structures that we are doing, because we will need it along the way. So at this particular stage, at this particular point, if there are no questions, I would like to say that we are practically done with tuples. And please do not just be looking at what we are doing. Also try to put your hands on your system or your IDLE, if you are using phone or anything, try to code something, because the next project that is coming, I do not know how we'll survive, but let's make sure that we get things done by ourselves. It's going to be the snake game, and we're going to use a graphical user interface as well. We're going to code from the very beginning. I'll do the coding. I'll show you step by step. We'll make mistakes and we'll correct the mistakes. If there are errors, we'll find a way out. And anytime we get, how we used to do it. So I will do it. I'll show you each step of the way, and I'll advise you as I'm doing it, you'll also do it, because once I'm done, I will also tell you to also do it and submit it as well. It's something that you have to do it hands-on and make sure it works for you. So I don't know how many persons will be interested in the next phase of the learning. It's going to be data science, and we're going to look at Python for data science. It's going to be Python strictly for data science, and we'll start using, I think I have a lot of data sets to share with you, practical data set that I'm using here in the workplace, and though I may add other ones from maybe Gaggle or other platforms, but we're using it live ones here. We'll be looking at, first of all, we'll look at data manipulation, data wrangling. That means preparing your data for modeling. By the time I know that we get set into the, because when it comes to real life scenario, at first when I started learning data science, I was going through Google. I'll download the data set. The data set is very clean. I'll use it for my data analysis, data science model. I'll build models, make the prediction. It will make a whole lot of sense. But when I got this job, I found out that clients will give you data that are very, very dirty. You do not even know how to even start. You just look at it. What is the end product of this data? What does the client wants to use this data for? You now start using data cleaning, you start wrangling the data, remove some things that are not necessary. If there are empty spaces, a client can give you a data that has empty spaces, like those cells, they do not have value. So if you start running your prediction immediately, you are going to have a wrong a prediction, and it's going to affect you as a person. So what you do, first of all, you learn, we go into data in Python. We have known Python. By that time, we have known Python enough. We get into how to make sure that we make this data clean enough. We wrangle the data, we sort it out, we do a lot of manipulations on the data. Once we finish that stage, we go straight into how we can make models. And I think I'll be opportunity to find a way to break things down and how you can understand the mathematical explanation of all these models. What is the support vector machine doing? What is the k nearest neighbor actually is? What is the mathematics behind it as well? If I'll be able to find a way to maybe draw on my screen, though maybe there will be a part I'll use a whiteboard and try to explain it in the mathematics aspect of it. But if not, data science has to also do with statistics as well. You have to know how things work as in kind of statistics kind of way for you to get things done. And don't worry, we're still going to get that as well. But the main thing is that data cleaning and data manipulation. It is, in fact, it is 70% of data science. It is 70% of data science, because now that technology has come in now, we can actually say, okay, there are a lot of models that we are pre-programmed already. You can just call it out and you just run it on your data. That is amazing. It makes your work much easier. You don't need to know the mathematics at some point, but when you get to interviews like that, they will ask you the mathematics behind certain models. That one you might decide to give it up. But at this stage, if you want to create models at this stage and make it work for you, you do not need to know like math like that. You just need to just bring out the model. Okay, this is what this model is using. Maybe a particular kind of task you want to do for a client. Maybe the client wants a particular one. Maybe you know the kind of model I should use. In this model, should I use a support vector machine? Should I use a random forest algorithm? Should I use what do we have, the HG boost? Should we use k-nearest neighbor and all those things and the rest? Should we use a neural network? Should we all those kind of stuff? So you know exactly which kind of model you should do. So that one is no issue. But the main thing is, I'm telling you guys, if you want to learn data science, the first thing first, the mistake I did was to start learning with clean data. When I started came here, my boss would give me God of mercy. I'll see data and I'll be like, it looks like something I cannot do. I struggled for months until I got to find a way out by myself. I had to learn from gradually looked at how it's been done. So I think I will clear that doubt for you at that stage, for you to make sure that once you are getting, if you are getting into data science, you that particular fear, that particular lack will be out of you. So talking from a very like a real world experience, if you're really going to data science, okay. So that's that's where we're going to stop tonight. If you're interested in the class, that one we're still there. We're still getting maybe by end of June we'll find a way to make sure that is possible as well. So if there are no questions, I think the next class will be either sets, either we look at sets as well, sets, and we look at sets, okay. So we see how we can make it work. After set, we'll look at comprehension, how we can do all those for loops that instead of doing for this, or you can just use list comprehension and make everything just like the lambda function of the main function. Instead of going through all those function steps, and just do it on one line and you're good to go. So thank you very much, and thank you for being patient with me. At some point, when it comes to my health wise and other things, you still believed in me and you still keep on learning, you still put in the work at some point. And like, I have doctors here, I have a lot of prominent people here that are putting their time to do their work. Like, for you to do those assignments and projects, sometimes like, yeah, that you're doing this thing, it makes me so happy that you're putting in the work, and it's going to pay off in the nearest future. I'm very sure, because the way the world is going, there are a lot of jobs that will be replaced by machines, and this is AI, artificial intelligence. So Python is one of the main tools, and Python is developing every day. Imagine Python coming in form of front end. You can use HTML and run Python as well, PyScript. So it's something that everybody is going to stick with Python. So if you have Python knowledge, you are getting there as well. Thank you, Dr. Solomon. Thank God I'm feeling better. I think when you are sick, you now value the fact that when you're healthy, it's actually wonderful as well. You can see that it's better now for me. And thank God as well. Thank you, guys. Thank you very much. And that will be end for tonight. We'll see you in the next class. That should be on Friday on Felony by God's grace. Bye for now.